ready to the countdown.
Tahniah! Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum, good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatiha. And for the non-Muslim, please recite your prayers according to your religion. Okay, how is everyone doing today? My prayer that everyone is in the best of health and ready to proceed with today's class. But let me introduce myself first. I am Madam Rosmaya as your moderator for today. I am from SMJKU Kajang Selangor, and together with us is Teacher Im, okay, our control host. She is from College Tingkatan 6, Tapah Perak, and our observer is Teacher Naini from Pusat Tingkatan 6, SMK Sultan Sulaiman, Kuala Terengganu. And the most important person today is our presenter, Teacher Zainariah Abdul. Okay, she is a very experienced retired teacher from SMK Tunku Ampuan Durrah Negeri Sembilan. So, let us give a warm welcome to our presenter. Okay, for the record, we are now live on Teacher Zainariah channel. So, as a sign of support to Teacher Zainariah for the hard work in preparing today's lesson, so please subscribe to her channel. Okay, not forgetting also to Teacher Im and Teacher Naini channel too. Okay, as usual, the lesson will last approximately for 1 hour. So the certificate link and the credit claim link will be given at the end of this session. And remember that you can only use EDD email to claim the certificate. IU credit is for you to claim present to motivate you to study more. And the more classes you join, the more credit you can claim. So be sure to follow the class up until the end and give your full cooperation in making this session a lively one. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture. It's possible your own picture if you wish to post comments in the chat box. Okay, I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any questions, please write on the chat box and Teacher Zana will try to provide you with the answers. So without further ado, please welcome Teacher Zana to start her presentation.
Okay, right. Thank you, Madam Rosmaya. Okay, first I'd like to thank all the teachers here, okay, for joining my lesson. Okay, kenapa saya? Okay, right. Okay, I would like to thank Teacher Im as the control, Madam Rosmaya as the moderator, and Cikgu Naini for observer. I think this class session will not be able to air, okay, in this stream yet. Okay, before I begin, I would like to say a little bit myself. Cikgu Zana channel, okay. Right, if some of you already subscribed my channel, you might be confused because in my channel, I am promoting mathematics M. So that I'm a teacher. I am a mathematics M teacher, but as a mathematics M teacher, I was teaching mathematics D. But due to a teacher retiring, so I have to take mathematics S. So I was totally mathematics S teacher. I'm teaching paper 1 and paper 2. Paper 1 is the same as mathematics T. So there's nothing to worry about. Familiar with the mathematics T syllabus. As when they introduced the modular system, I become a mathematics M teacher. S become M. So everything was changed. Okay, SEM 1, SEM 2, SEM 3. And SEM 3 is entirely different. It's not the same as mathematics S because we have the management mathematics. Okay, so M is referring to all students who are doing account. Okay, so please, guys, do not confuse. The M is not typo error. It is M, mathematics T. Okay, right. Students, take note for this. You miss all the live classes, don't worry, because we have already created this for all the online classes. So you can check the playlist for the SEM 1, Algebra, and Geometry, okay, free online classes, and also have the SEM 2, okay, online classes. Okay, that's the playlist, and also SEM 3, okay, all the online classes. So nothing to fear. If you miss the online classes, check the playlist. Okay, we have already created a playlist containing all the video lessons each semester. Okay, we have the SEM 1, okay, we have the SEM 2, those SEM 3 playlists. Okay, if you cannot write down, okay, you can always screenshot and then view later, okay, so that the numbers of views will increase. And also we have a collaboration of the mathematics teacher, okay, which consists of matriculation and STPM. Okay, in this playlist, you can find mathematics matriculation and mathematics. So we have Cikgu Khairul Azwat here. We are waiting for him to join us online. And Puan Ong, Madam Zainariah, and Madam Shakina, okay? And then we have the PU lesson collaboration list, which consists of video lessons, okay, from the chemistry, okay, head by Jess Shannon, okay, and have the biology video lesson head by Cikgu Faiza, and also have the physics video lesson head by Madam Musmaya. She's our moderator today. And last is the economy and perkawanan STPM and matriculation lesson. Okay, let's start our lesson for today. But before that, I would like to share the first code for today is for the mata credit, yeah, is A1. A1, okay, students, A1. Okay, today's is on integration by partial fractions. Okay, now it's quite easy if the students are familiar in expressing fractions into partial fractions. Okay, so once you are able or you have this in expressing fractions, partial fraction, you won't have any problems integrating. Student, integrating by partial fraction is very important. Why? Because you'll be needing this when in integration by parts, integration by substitution, or in application of integration, that is finding the area or finding the volume of revolution. Hence, although it is simple, but integration by partial fractions is also important. Okay? Right. Now, let's recall back because partial fractions decomposition, you have learned this in semester 1, okay, in algebra. Okay, let's say that you have rational function. Remember what is a rational function? Okay, it is a fraction, okay, where the numerator and denominator are polynomials. And the rational function can be decomposed into partial fraction by following 4 rules, okay? 4 rules. Okay, you can read PDF notes. If you do not have the PDF notes, I already shared the link to my drive. You can always go to download from the drive, okay? Okay, now let's say the first rule, okay? For example, the first rule, we have this fraction, rational function. To identify the format of the partial fraction, we always look at the denominator. Okay, for this fraction, okay, this is a fractional function. Okay, you look at the denominator. Okay, the denominator corresponds to linear. So this is the first rule. This is called linear factors because x is to the power of 1. X is of 1. So since the denominator of linear, so this fraction can be decomposed into partial fraction of the form a over x plus 1 plus b over 3x plus 2. Okay, this is important. It's just finding the values of a and b. Okay, we will do this. So this is the partial. You can always how by 5 with 3x plus 2 minus plus 1. You should get the same numerator, 2x minus 3. Okay. Next fraction, we have 7x over x plus 1 squared. Okay, again, we look at the denominator. Okay. The denominator corresponds to what type of factor? Anybody wants to answer this? Okay, there's Cikgu Nun and Cikgu Reha in the StreamYard. Okay, Cikgu Nun, hi Cikgu Reha, thank you for joining. Okay, what is the denominator here? X plus 1 squared. This is the repeated linear factor. Okay, so the form of the partial fraction is a over x plus 1 plus b over x plus 1 squared. Okay, notice that here at the end is the same as the x plus 1 squared. So again, we solve for a and b. So this will be our partial fraction. Okay, you check. It will be 7x. Next. Okay, we have x plus 1 over x squared, 5x plus 1 over x plus 1. Okay, we look first factor of the denominator. Okay, x plus 5x plus 1 correspond to a quadratic factor. So when it corresponds to quadratic prime factor, the partial fraction is of the form a plus b over x squared plus 5x plus 1. Next, we have here another factor, which is a linear factor. Okay, now if it's a linear factor, the partial fraction is of the form c over x plus 1. Okay, again, we solve for a, b, and c, have this as the partial fraction. Not all the fractions given here, okay, all here are rational functions, but notice that all the rational functions given are proper fractional functions. Okay, can anybody, students, can anybody tell me how do you determine that is a proper fraction? Can anybody tell me? How can we identify that the fraction is a proper fraction? All three are proper fraction. Why? Please type in the chat box.
Okay, come on, student. Let's try the answer.
I purposely just gave you about 9 questions today, simple 9 questions, because I want you to interact with me in the stream. Yeah, can anybody tell me? How can we identify an equation is a proper fraction? Okay, a fraction. This one is a fraction. So why do I call this a proper fraction? Similarly here, how do you identify a proper fraction? If you read my notes, there is the answer there. Anybody? There's how many of you here? 15 of you here. Okay, can any one of you just tell me why proper fraction? Okay, tak apalah. Just 15. Probably they are still shy. Okay, we not. To identify is a proper fraction, we look at the degree of the numerator. Okay, numerator is the top one, and the degree of the denominator. Normally for proper fraction, degree of the numerator is always less than the denominator. Okay, so that is a proper fraction. Okay, tadi Syafiq did say, okay, Syafiq, thank you. Okay, next. So all these proper fraction must follow these three rules. Now, what are proper fractions? We know there is an improper fractions if the degree of the numerator is greater or equal to the degree of the denominator. So what must we do? We need to simplify the numerator with the denominator. Okay, so here have a rational function. Notice the denominator is the power of 2, the degree is the power of, and the numerator, the degree is to the power of 2, meaning the same. So we simplify using long division. I prefer long division. Some teachers will put plus, they put a constant and they have to find the constant quotient. But it's easy to use long division. Learning tip. Since the degree of the numerator is the same as the denominator, then our quotient will be a constant. Do the long division here. So we divide, okay, 1 by x squared minus 1, we have x squared minus 1, and the remainder is 2. So this fractional has become, there's another learning tip. If so happen the degree of the numerator is greater than the degree of the denominator n, then the quotient will be a polynomial of degree minus m. But here we have the same, 2 for the numerator, 2 for the denominator. And we have is the quotient plus the remainder over the denominator. Okay, so next what you must do, okay, you need to decompose this into partial fraction. Again, we have to look at the denominator. We have here x squared minus 1. So is it a quadratic prime? X squared minus 1, is it a quadratic prime? Just answer yes or no, students. Answer yes or no. Yes, is it a quadratic prime factor? It's very important that you need to, find the denominator, because from there to form partial fraction. So is x squared minus 1, is it quadratic prime? It's a yes or no. Then, I think students are still sleepy. Okay, right. It is not a quadratic prime because you can factorize. So you factorize, it becomes x plus 1. So the denominator to linear factors. Hence, the form will be 1 plus a over, yes, thank you, Mei-Ling, it's no, okay? Thank you, Mei-Ling. X1 plus b over x plus 1. So again, we solve for a and b, and we get a as 1, b as 1. Later on, we'll do the detail, okay, in depth. This is just to how to decompose fractional function into partial functions, okay? Okay, now we can start our lesson. Number 1A. Okay, read the question. You need to express the function in each of the following integrals in partial fraction. Okay, that's the element must express in partial fraction, and hence baru you the integration. Okay, starting off 2x over x plus 1x minus 2. Again, can anybody identify the denominator? What type does it correspond to? What factor does it correspond to? Remember, we have the three rules. We have the three. Yes. Is the denominator correspond to? Anybody just type? It's linear, quadratic prime, repeated linear. What is it? I guess students are quite shy this afternoon. Okay, it's a repeated, sorry, it's not repeated. It's a linear factor. Okay. Both are linear factors. Hence, correspond to a over x plus 1 plus b over x minus 2. Okay. Hence, we multiply both with the denominator. Okay. So we have 2x equals a times x minus 2 plus b times x plus 1. Okay. Now we need to solve for a and b. Okay. Choose any value of x. So be smart, work smart, choose any value whereby it's easy for you to find A or B. So I'm choosing X as negative 1. Liao Yi, thank you Liao, okay, for writing down form of the partial fraction. Good, good. At least you are following my lesson, Liao Yi. Okay, so choose X as negative 1. So this becomes 0. The left side becomes negative 2, negative minus 2 is negative 3a, b becomes 0. Hence, is over 3. Okay, now, choose x as 2. So your left-hand side is 4, but your right-hand side, a becomes a times 0 is 0, 2 and 3. So your b is 4 over 3. So you must conclude your answer because it's required the question. So this is our partial fractions. Okay, hello, Madam Fizi. Madam Fizi is in the stream yard. Thank you, Madam Fizi. Okay, so we have this. So now we integrate. Okay, right. I'm doing this by function. So I know you can straight away integrate, but this is to help those average so that this is how we do the integration. So we're going to apply the integration of f prime. The integral of f of x is ln of x. So notice that here, derivative of x plus 1 is 1. So we have 2 ln x plus 1 modulus. We have 4 over 3 ln x minus 2 c. Now, we need to simplify our answer. So we look here at the coefficient. We have 2 over 3, 4 over 3. So we take out the common factor. The smallest which is 2 over 3. So we have 2 over 3 ln x plus 2 ln x minus 1 get plus c. Okay, you can check by multiplying again. This is 2 over 3 ln x plus 1, 2 over 3 times 2 over 3 ln x minus 2. And then applying the loss of logarithm for power, we have this. Okay, and then the loss of logarithm for product, we have this. Hence, this is the final answer. Okay, so it's easy. The first one is always easy. Okay, next. B. Okay, looking at the partial fraction, can anybody describe the denominator? So, right, I will give the answer. This is a factor that can be factorized. Okay, so this is the factorization of 2x squared plus x minus 1. Hence, it corresponds to linear factor. So the form of partial fraction is this form, a over 2x plus 1 plus b over x plus 1. So again, you multiply both sides by the denominator. It's easy. 2x minus 1x plus 1, this. Then choose a value of x. So I'm choosing x as negative 1. So my left side is 3, my right side is negative 3b. Here becomes 0. So b is negative. Next, choose x as what? Choose. Okay, I'll choose x as half so that my b is. So my left side is 4.5, 9 over 2. My right side is half plus 1, 3 over 2, 8. So my a is 3. Okay, so this is our partial fraction. Okay. Once you get the partial fraction, you can integrate. Okay, we integrate. So I would like to integrate function by function. Why? Because notice that we're going to apply again the formula f prime x over f of x. But that when you did 2x minus 1, but the original function we have 3. So how do we get this? Teacher Im has already taught in last lesson. How can we get the same as integral 3 over 2x minus 1? So what must you do? Can you write on the block what you do so function and this function will be the same? You learned this last week during teacher lesson. What must you multiply or must you divide? Anybody? I'm waiting. Okay, while waiting, the second code is number 9. The second code to claim your credit is a number 9 or digit 9. Okay, I repeat, 9 second code. Okay, nobody is answering me. What must you do so that it becomes the original integral 3 over 2x minus 1? Okay, we multiply by 3 over 2. Hence, this integral and this integral will be the same. Okay. So now we are in business. So we can apply the rule. So we have 3 over 2 ln 2x minus 1 minus ln x plus 1 plus c. Again, we use the logarithmic laws of power and then the logarithmic law of quotient. So you have ln 2x minus 1 to the power of 3 over 2 over x plus 1 plus c. Okay, so you need to simplify your answer because when we integrate, we are actually finding the equation of a curve to simplify your integration. Okay, next. Okay, C, let's identify our denominator. Okay, the first one, let's try, class, what is it? X minus 2. What does it correspond to? This is repetition of some topic, a partial fraction. So I'm afraid most of you have forgotten. That's why I give you the notes. So X, okay, mailing repeated. Okay, Xiaoyi, okay, thank you. Mailing, Ziuyi, is it? Okay, repeated linear factor. Good. So the form is just A over X minus 2 plus B over X minus 2 squared. Next, we have here linear factor. The form is 2x plus 3. Okay. Right. Now, so again, we multiply with the denominator on both sides so that we can solve for A, B, and C. So again, I advise you to work smart, choose a suitable value so that it's easy for you to find the values of A, B, C. Okay, let's look. Choose x2. So here becomes 0, here becomes 0. So you are left with 14 minus 2, 12, 7b. So b is 12 over 7. Okay. X is minus 3 over 2 or negative 3 over 2. So that b is here vanishes. So you are left with c here. Okay, it's not a nice number, but you have the calculator, you calculate. So your c is negative 50 over 49. Okay. Next, x0. Why? Because so that here we have negative 2 left side, negative 2 times 3 is negative 6a, 3b plus 4c. Negative 2 squared is 4, okay? So we substitute b, the values of b, value of c, so your a is 25 over 49. Okay, there's another method, okay? If you find that this method is tedious, we can compare the coefficient of x squared. Okay, notice that here, left-hand side, okay, there's no x squared. So we put 0. Left side is 0. Hence, on the right side, 2x times 2x is 2x squared. So times a is a. Let's write down the alphabet a and the coefficient. You don't have to write down x squared. We just write down the coefficient to a. Here, x times C, so C. We know that C is negative 50 over 49, hence your A is 25 over 49. It's up to you class to choose which method you are more comfortable with, okay? So main thing is that you find partial fraction, so substitute A, B, C, we have this. Okay, now time to integrate. Okay, let's do function by function. Okay, so the first one, 49 is taken out, the integral of 1 over x minus 2 plus taking out a constant 12 over 7. So here becomes x minus 2 to the power of negative 2. And here we have minus 25 over 49, 2 over 2x plus 3. Okay, notice that why I have taken out only minus 25 over 49. Because I'm going to use the rule or the formula, the integral of f prime of x will give you ln f of x, okay? So the first one, what is the integral? Okay, we have this. The second one, using the composite rule, you have this and okay. So now we take common factor. Okay, and we have simplify this here. We have minus 1x plus c. So simplify further by applying the laws of logarithm of quotient. So this, okay, right. I think it's already time for
Okay, so
iklan.
we better take a break now.
Yes.
Okay, we take a break with the advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back students. Teacher Zana, you may proceed with your presentation now.
Okay, thank you, Madam Usmaya. Okay, I think you have to hurry because okay, let's look. So look at the denominator. We have x3, x minus 2, x minus 3. What do you think is the form? X squared minus 3. Okay, it is a quadratic prime factor. When we say quadratic prime factor, meaning that we cannot factorize, okay? Meaning that it's irreducible, okay? It's irreducible. So the form of the partial fraction for quadratic prime factor is ax plus b over x squared minus 3. And if you have x minus 2, it's a linear factor. The form of the partial fraction is c over x minus 2. So again, we multiply both sides with the denominator, x squared minus 3, x minus 2. So we have this. Okay, x squared minus 4x plus 3 equals ax plus b. Okay, x minus 2 plus c, x squared minus 3. Okay, choose any values of x. Okay, I will choose x equal to first. Why? Because a and b will vanish. So my left side will be 4 minus 8 plus 3, negative 1. And this one will be 4 minus 3, so c. So c is negative 1. Then I choose as 0. So my left side will be 3. Here is 0. So I have only b. So negative 2b minus 3. So substitute c as negative 1. And b is 0. And then let x equal 1. So you have to do your, okay, calculate 1 minus 4 plus 3 is 0. So a plus b, negative 1. So here c negative, so 1 minus 3 is negative 2. Okay, substitute your b and c. So you have a as 2. or I would prefer comparing of x squared. So left side x squared is 1. Here a, because a will be multiplied by x squared, and then c x squared. So my c is -1, thus our a is 2. So comparing coefficient is simpler, in fact, compared to substitution values. So this is our partial fraction. Okay, substitute your a, b, and c. Okay, now we are in business, we can integrate. Okay, can we do the integration now? So what is the integral of 2x over x squared minus 3? Anybody?
Okay, let's try, student.
Yeah, let's try. Hi. Because if you notice that from A, B, C, D, formula for integration that we use is just integral of f prime x over f of x, which is ln f of x. So notice that here, x squared minus 3, the derivative will be 2x. So we have this. Similarly here, derivative of x minus 2 is 1. So we can apply the formula. Don't forget plus c, because this is indefinite integration. Again, you simplify. Let's apply the laws of logarithm for quotient. Okay, so you have the answer. Voila. Okay, next. Okay, can you tell me proper fraction? Is proper fraction yes or no? Okay, it's a yes or no question. Can everybody tell me? Is it a proper fraction? Yes or no?
Okay, come on, students. Yes or no?
I know there's 16 of you watching. Is it a proper fraction? Okay, there's an answer there. What? There's no answer.
From
Anybody?
Shafiq. No, from Cikgu Shafiq.
Okay, no, yes, it's proper fraction. So it's improper. Why is it improper? Shafiq? Improper. We look at the fraction. Notice degree of the numerator is 2. The degree of the denominator is 2. Because when you expand this, it's squared plus x. Okay. So since the degree of 2 and the denominator is also meaning that are equal, so the quotient is a constant. This is checklist. Okay. This is just a checklist for us when we do the long division. Okay. So here x squared plus x plus 5 divided by x squared plus x. So we have 1 constant. So the remainder is 5. Hence, we simplify the fraction 1 plus x times x plus 1. So we have here, we need to decompose into partial two linear factors. Okay. So since they are linear factors, again, we know that it's of form a over x plus b over x plus 1. So again, we need the values of a and b. So multiply by with the denominator. So we have a times x plus 1 plus bx. Okay, choose any values of x. X is 0. A is 5. Then when x is -1, b is -5. So it's quite simple. So the partial fraction is 1 plus 5 over x minus 5 over x plus 1. Okay, now we are ready to integrate. Shall we do this together? So what is the integral of 1? Very simple. What is the integral of 1? Student, Simple, I think the Form 4 student, the Form 5 students can answer this. So what is the integral of? Very simple, the integral of at maths, Form 5 at maths student, yeah, they can do this. Simple, integral of 1 is, instead of I split it to functions, okay, you can straight away integrate. So the integral of 1, anybody?
Get one answer here from Sinchai, X.
Okay, yes, good. It's just X. Good, Sinchai. Izani, good. X. Okay. It is X. Okay, next. The integral of 5 over Z. Just right. What is the integral of 5 over X? 5 is a constant you can take out. By now, you should know because this is a basic integration. I have not shown you any complicated function. It's direct function. So what do we have? Integral of 5 over X is? Okay, we are running out of 5 ln X minus 5 ln X plus 1 plus C, okay? So we can take out the 5 to simplify. So again here we apply the laws of logarithm of quotient. So we have this, okay? So quite simple, isn't it? Okay? Okay, now again we have an improper fraction. Here the denominator is greater than the degree of the
Sorry to
denominator.
interrupt. Sorry for interrupt, Teacher Zaina. Maybe we can announce before we start question F.
Third
Announce
code. Third code. Okay, the
yes,
third
the
code
code.
is number 8. Okay, number 8. Okay, please take note is 8. Okay, so we divide using long division. Okay, the quotient is a linear function. Okay, I've written here slightly different from the numerator. We have x to the power 4 plus 1. The purpose I do this because it's simple for us to place our value. Okay, since the code is a linear function, hence I can place my x right under this. So x times x cubed is x to the power 4. X times 2 is 2x squared. Okay, so this is how we do division. So the remainder will be minus 2x plus 1. Hence, the rational fraction written into partial fraction plus proper fraction, yeah, plus 1 minus squared over x times x squared plus 2. So we need to decompose this into partial fraction. Okay, right. My practice is that when there's a negative, I would like to put the positive so that I don't make any mistakes, okay? So here's a linear factor, so the form is AO. Here is a quadratic prime, so bx plus. Solving to get A, B, and C, so you multiply with the denominator, so we have this. So again, x is 0, okay, we have 1 on the left side, 2a plus 2a. So a is half. Then I compute the coefficient of x squared. So I have minus 2 on the left hand side, a plus b. A is half, so my b is negative 5 over 2. And I compare the coefficient of x, okay? So there's no x on the left side, so it's 0. Here only c is the coefficient of x, so c is 0. Therefore, our rational function is plus 2x minus 5x over 2x squared plus 2. Okay, now we are ready to integrate. Again, the integral of, okay, so we have x squared over 2 plus 1 over 2 ln x minus, okay, for this integral again, okay, we're going to use the rule on f of x, okay, assume matter. So we have negative 5 over 4. Okay, so that it becomes equal. Hence, you have negative 5 over 4 log x squared. Okay, then we have this. So we factorize. Okay, we simplify using the loss of logarithm of power here, then using the loss of logarithm for quotient, we have this. Okay, right, there's a question here why I'm using level question, because this tuition is not only meant for good students but also for weak and average students. Okay, so it's a tuition class. Okay, right, number 2. So here we need to express in this form, okay, and then show that the integral of this rational function from x1 to 3 is 1 pi over 4. Okay, notice that a over x plus bx over x squared plus 1 plus c over x squared plus 1, okay, is the same as a over x plus bx plus x squared 1. Okay, it's the same because both have the same denominator. So we can combine the numerator. This is for easy calculation, okay? Hence, again, we multiply both sides x squared plus 1, okay? So we choose x0, left side will be 2, okay? Here will be a, here will be 0, so your a is 2. Then comparing the coefficient of x 4, a plus b. My a is 2, so my b is 2. Next, I have comparison of x. So left side is 3, okay? Here there's no x, we have only c as the coefficient of x. So our c is 3. Therefore, okay, you need to write in this form. You need to write in the form asked in the question. Okay, 2 over x plus 2x over x squared 1 plus 3 over x squared plus 1. So now we need to show that the definite integral of this rational function from x to set 3 is ln 6 plus pi over 4. Okay, alright, sorry. If you do this, boleh juga. The same but given, you get the same partial fraction. Now, let's do it together. So what is the integral of 2 over x? We have 2 ln x. The integral of 2x over x squared plus 1 is ln x squared plus 1 plus, okay, now. Here, notice that we have 1 over x squared plus 1, okay? Prime. Are you going to change further into partial fraction? But teacher Eileen's class, if you can recall back teacher Eileen's class, okay, this form. So a is actually 1, okay, a squared, 1 squared is 1. Your f of x is x, okay? So when you differentiate x, we have 1, okay? So we have of x. So the integral is the inverse of tan x, the inverse of tan x. Or like myself, I always memorize this, okay? Because we know that integration is the reverse of differentiation. We know that tan x is 1 over x squared plus 1. When I see this, okay, straight away, I remember this. But up to you, how you memorize the formula is your choice, okay? So we have these 3 tan x. Okay, now we substitute the upper limits. 2 ln 3 plus ln 3 plus 1 plus 3 tan 3. Okay, then we substitute 1, 2 ln 1 plus ln 1 plus 3 tan 1. Okay, okay, we know that, okay, here 3 to the power of, we the loss of the logarithm, 2 times half ln 3 plus ln 4 plus 3 times pi over 3. Tan 3 is pi over, okay, class, the calculator, make sure is in radian mode, okay. 2 ln 1 is 0, ln 2 plus tan 1 is pi over 4. Okay, the rest is just calculation. Then forget the rules of rules, okay. This is this pi. So you have ln 6 plus pi over 4, hence shown, okay. Okay, next. Okay, this is a past year question during STPM year, where dulu ya mathematics T is the same as mathematics S. Okay, so again, okay, fraction. Okay, you can substitution, but the question say use partial fraction. You must answer based on the question requirement. You use substitution and you get the same answer as this, you get 0 mark because the question asks you to use partial fractions. Okay, now we have here a repeated linear factor. So we have a over x minus 1 plus b over x minus 1 plus c over x minus 1 cube. If we look at my notes, okay. Okay, next we simplify by multiplying x minus 1 cube on both sides. On both sides here, so we have this. Okay, so now choose x1, a and b disappear. My left side is 1, so my c is 1. And I choose, I compare the coefficient of x squared. So this is 1. Okay, so my a is 1. This is coefficient, b is coefficient of x. So now we let x is equal to, my left side is 4. So 2 minus 1 is 1. So a plus b plus c. Substitute and c. So I have my b as 2. Okay. This is a partial fraction. Okay. Hence, we are ready to integrate and substitute the lower and upper. Okay, so what is the integral of 1? Okay, sorry students, you have to rewrite this form x minus 2 to the power of negative 2, and you have to write in this form x minus 1 to the power of negative 3, so that it's easy for you to Somebody tell me what is the integral of 1 over x minus 1. Okay, can I ask Sandy A to answer me? Sandy, if you are there, can you, because this is a level question. Okay, so what is the integral of 1 over x minus 1? Or anybody else in the class, can anybody answer me? What is the integral of 1 over x minus 1? Students, please think, not everybody of you here are intelligent. I'm starting off with an easy question for the weak and average students, okay? So that's why my class started a simple question and we grew up eventually, gradually, okay, from easy to difficult level. So what is the integral of 1 over x minus 1? Anybody?
Okay, let's try, student.
Yeah, let's try. We've been doing the past 7 questions, same format. So the integral of 1 over x minus 1 is just ln x minus 1 using formula. Here, composite rule formula. Okay. So here is negative 2 plus 1, negative 1 divided by negative. Okay. So simplify, we have minus 2 over x minus 1. We substitute here, we put this. Again, here we use the composite formula. Negative 3 plus 1 is negative 2. You divide by negative 2. So we have negative 1 over 2 times x minus 1 squared. So we have integral. Okay, next we substitute the upper limits. Ln 3 minus 1 is ln 2. Minus 2 over 2 is minus 1. Minus 1 over, okay, 3 minus 1 is 2 squared. Okay, 4. 4 times 2 is 8. Minus, okay, substitute 2, ln 1 minus 2, okay, 1, 2 minus 1 is 1, so minus half. Okay, now we know that ln 1 is 0. Okay, so we have 11 over 8 plus ln 2, okay, right, shown. Okay, Okay, next. The last one. Again, this is what I meant. Sometimes fraction when we use technique of substitution. Okay, read the question here. I forgot the question. I thought it's 3 questions. Okay, the first part is to show that when you substitute u as e to the power of x, we can change this in terms of u and then use partial fraction to find the value of the. Okay, let's see. I'm going very fast. I'm so sorry, class, because I forgot there's one more question, 4 minutes left. Okay, given u as e to the power of x, so limits when x is 0, your u is e to the power of 1. When x is 1, your u is e to the power of 1 is e, okay? So now we need to convert dx in terms of du. So differentiate du of x is x. What is ex? Ex is just u. So from here, our x is du over u. So next we substitute everything in terms of u. Okay, first change the limit from 0 to 1, 1 to e. E to the power of x is u minus 1. E to the power of x is u plus 1. So multiply by du over u. So you rewrite this, hence we get the same form as what given in the question. Okay, you multiply this out, you get the same form as what given in the question. Okay, next the question asks you to use partial fraction to find the exact value of the integral. So again, we have to change to fraction because this form, because the denominator corresponds to linear factors. So again, multiply both sides with the denominator. So we have u minus 1 equals a u plus b. Okay, choose u as 0, we get a as negative 1. Choose u as negative 1, we have b as 2. Thus, our partial fraction is negative 1 over u plus 2 over u plus 1. So we are ready to integrate. Okay, so again, like I said, I would prefer the positive value in front and negative value at the back. So what is the integral of 2 over u plus 1? Anybody? Okay, tak apalah. So we are running out of time. It's 2 ln u plus 1 minus ln u. Substitute the first limit, the upper limit as e. And then we substitute the lower limit 1. So ln 1 is 0, ln e is 1. So we have 2 ln e plus 1 minus 1 minus 2 ln 2. So we have, okay, now we use the laws of logarithm, quotient. So we have e 1 over 2 minus 1. Okay, this is the exact value. To convert to decimal values is no longer exact value, it's just an approximation because you round off to 4 significant figure. So the exact value is in terms of ln and e, okay, student? So by now, I think you can see the how we change to partial fraction and the integration by partial fraction. Okay, if we find that this class is not up to your standard, I will not apologize because I'm creating this class for the weak and average students because my principle is to have all level of to understand how to integrate using partial fractions. Okay? So I pass over to Madam Rosmaya, but before that, last quote, okay, as a token for being faithful in attending the class from beginning till the end. Okay, the last quote is number 5, digit 5. Okay, I pass to, that's all class, so I'll pass to Madam Rosmaya, and and I apologize if saya terkasar bahasa dan sebagainya sepanjang siaran. Okay, Madam Rosmaya, over to you.
Okay, so with God's grace, we have reached the end of today's session. Okay, congratulations to those who are able to follow our session from the beginning till the end. Before we end our session for today, so can all of you please stop posting all comments for a while and click the subscribe button and activate the icon bell so that you will not miss the next class session. Then if you find that the lessons was beneficial, click like and share to all your friends on your social media, spread and share the goodness. Okay, once completed, type done on the chat box before the certificate link is given. I think given already, right? The certificate link is given as a token of thank you for your dedication in joining the free online class today. So, okay, link for the certificate and link to claim credit are already given in the chat box. Okay, so please take note, the link will end half an hour after this live. Make sure to use the EDD email only to log in. Okay, incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. If you wish to get more information on the online classes, go to the www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. Okay, so once again, I would like to thank all of the students for joining today. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is a collective effort from all the teachers throughout Malaysia and for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. Okay, I think that's all for now. See you in another session. Ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. Stay safe. Still we meet again next week, same day, same time, which is on Saturday at 5 p.m. Okay, bye-bye.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus gancaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.